Hello, this is Dr. Bitla Venu coming in front of you with a new topic in today's session, that is projections of planes. In my last session, we have seen projections of points and lines in different cases. Also, we have discussed when the point is in different coordinates, when the point is in front of VP, when the point is above the HP, and lying on the planes itself, we have seen. But in the case of the projections of the lines also, we have seen the different cases when the line is parallel to HP, when the line is parallel to VP, when the line is parallel to inclined to HP, inclined to VP, and also when the line is inclined to both the planes also we have seen. But in this session, we will discuss the projections of the planes. Now let me move further to see the different cases in projections of the planes. Now, in the projections of the planes, in this topic, the plane figures may be anything. It can be a rectangle, it can be a circle, or it can be a hexagon. It is, normally in the problems, they use it to ask us to draw the front view, side view, top view when a plane is located in the different situations. Like as I said just now, the plane can be inclined, the plane can be parallel to the reference plane. So we will see how this will be described in the coming slides. So normally in the problems, they use it to ask us to draw the projections of the front view, top view, and side view of the planes. In the different cases, when the plane is placed with different criteria, with the different conditions, in those conditions, we have to draw front view, top view, and side view. Then in the problem, they will give us the description of the plane figure. They will give us the description. That means what exactly the figure is. The figure can be a rectangle, the figure can be a hexagon, or it can be any triangle shape. It can be any shape. The description of the figure will gives us in the problem. Then its position of that plane with respect to HP, horizontal plane, and vertical plane will also gives us in the problem. Then in which manner the plane is located. That means whether the plane is making some angle with the reference plane. That means the inclination of the plane with the reference plane, the inclination of the surface. Otherwise, in this case, you consider it as a surface now, as of now. So inclination of the surface with respect to the reference planes will also gives us in the problem. Then inclination of its edge. Sometimes the inclination of the edge will also gives us along with the inclination of the surface. If is not given the inclination of the edge, we can leave that, but otherwise in some specific cases, they gives us along with the inclination of the surface, they also specify as the edge of the surface can also make some angle with the reference plane. That data will also gives us. That means normally in the problem, they ask us to draw the front view, side view, and top view of the plane. Then in the problem, they gives us the description of the plane, then its position with HP and VP. Position means with how much distance the plane is located with respect to the reference planes. That values, those position coordinate values will also gives us in the problem sometimes. If is not given the coordinate values of that plane or the position, we can locate the plane with reference to the horizontal and as well as the vertical planes with the assumed values. If he's given the exact values, we need to consider the exact values. Otherwise, the arbitrary values must be assumed and locate and draw the front view, side view, and top view of the plane. Then in the problems, as I said, they will also give us the inclination. We need to consider the inclination with respect to the reference plane. And even in some cases also, the edges of the planes will also gives us to draw the front view and side view, top view of the plane. Now let me move further to see to see the different cases. Then I'm taking rectangle in this case now. Now the surface is parallel to HP. Now the plane that we are going to assume as parallel to HP, rectangle I am considering. Then the second case I am going to assume here is surface is inclined to HP. Then in this case the surface is parallel to HP and the surface is inclined to HP. And the third one is one small edge of the surface can be inclined to HP. So like this. Now let us represent the plane or the surface with respect to the reference planes. So those are horizontal and vertical planes. The first case, as I said, it is parallel to HP, the assumed surface. The assumed surface or the plane is parallel to vertical and as well as the horizontal planes like this. That means in this case, so please, the first case is that the surface or the assumed plane, the rectangular plane here, is parallel to HP now. It looks like this. Now the second case is the plane is inclined to horizontal plane. This is exactly the horizontal, and with the horizontal, this plane is making some angle with the horizontal like this. Then one of the small edge of this surface or the rectangular plane in this case is making some angle with the vertical plane like this. Okay, so these three cases are we are going to come across in the coming problems. Now let us try to draw the projections in these three cases now. Now take the first case. Let us try to draw the projections. So those are the front view and top view. When the observer is perpendicular to the reference planes, that means whenever we are drawing the front view for this rectangular plane, the observer must be perpendicular to the vertical plane. Whenever we are drawing the top view for this rectangular plane, the observer must be perpendicular. That means at the top of this horizontal plane, exactly perpendicular to the horizontal plane. Now, this will be our front view. That means, and this will be projected in the front view. This rectangular plane is exactly parallel to the horizontal plane. It's not making any angle and it is not doing any angle with the horizontal plane. So it looks like a horizontal line in front view. That horizontal line is projected onto the vertical plane like this. Then when you see from the top, we will get a true shape of this rectangular plane. Then that will be projected onto the horizontal plane with the true dimensions of the rectangular surface. I'm naming this as FE1. So front view 1 in this case, then top view 1 with these conditions. Now let us come to the second case. In this case, the plane is making some angle with the horizontal. Then the front view looks like an inclined line which will be projected onto the vertical plane like this with a given angle. Then when you see this inclined surface from the top, then the true shape will not come. In the first case, we will get the true shape because the plane is exactly horizontal or the parallel to the horizontal plane, so that we will get the true shape in top view. Then in this case, we will not get the true shape. We will get the imaginary shape or the arbitrary shape or the reduced shape we will get. The exact size in the first case will not match with the second case. When you see from the top, it will be projected onto the horizontal plane with the reduced size like this. Then in the third case, when you see from the top, and it is also a shape which is making some angle with the horizontal. Then in the top view also we will get the reduced shape like this. In both the cases, we will get the reduced shape and we will not get a straight line like the first case and the second case. Now let us try to draw the actual drawings for these three cases. As I said just now, in the first case, the top view will be the true shape, as I said, because the plane or the assumed surface, rectangular surface, is parallel to the horizontal plane, so that when we observe this from the top, we will get the true shape. True shape means whatever the dimensions which are given in the problem, so with those dimensions, we will get the shape. In this case, when the given surface is parallel to the horizontal plane or HP, the top view will be the true shape. Then the front view is a line and which is parallel to XY line. XY line here where vertical plane and horizontal plane is meeting. So that line, I mean that point, that where these two planes are meeting, that line we are calling as XY line in this case. So when the plane is parallel to HP, so top view will be the true shape. Then the front view will be a line which is parallel to the line where HP and VP is meeting, that is XY line. Now draw XY line first. This is our XY line. Above the XY line will be our vertical plane. As I said, the front view is a horizontal line. Then top view is the true shape. First we have to draw the true shape when the plane is parallel to HP first. After drawing the true shape, then project these points to the top. I am naming these names as A, B and CD. When you see from the front, so AB, B, A, B dash, A dash and C dash, D dash will come like this. I remind you once again, when the given surface is parallel to HP, the top view will be the true shape, the front view will be the horizontal line which is parallel to XY line where VP and HP is meeting. Then let me move on to the second case. In this case, the front view is an inclined line. The top view will be the reduced shape of the actual size. Now draw the inclined line with a given dimension, with a given length, then A dash, B dash or C dash, D dash, whatever we have drawn here, A dash, B dash and C dash, D dash. Then this line is going to make some angle because in front view, this plane looks like a vertical line and this plane is making some angle with horizontal. That's why in this case, whatever the angle given in the problem, with that angle, project or twist this surface with that given angle. It also looks like a straight line with a given inclination angle. Same line we will get here, same dimensional line we will get here, straight line we will get here, but with given inclination, which is making the angle with the horizontal plane. When the plane is making some angle with the horizontal plane, in that case we have to draw or the project this surface above the xy line. When the surface is making some angle with the vertical plane, so this projection will come below the xy line. So that we will see in the coming slides. So now in this case, so this surface is making some angle with the horizontal plane, so that we have to draw or draw the projection of this inclined surface above the xy line. When you see from the front, it looks like a line which is making some angle here. That line we're drawing here. This is exactly the front view when the plane is making some angle with HP. Now, when you see from the top, project all these points to the down, then project the points in the first case, AD and BC. I'm naming all these points as A1, B1, C1, D1 in the second case. And the front view is obvious, which is making some angle, A dash, B dash and C dash, D dash. There is no change at all, but it is making some angle. But here the plane is horizontal, but here the plane is making some angle with the horizontal. With that angle, we have represented this plane here. Then we have projected. As I said, when you see from the top, the true shape we're not going to get. The shape that we get is the reduced shape. The top view is a reduced shape. When we twist the surface with some angle with the horizontal, when you see from the top, the surface is not the true shape. The plane is not the true plane. We will get the reduced plane or the reduced shape. Then after this, the third assumption or the third case can be one of the edge. In this case, the small edge of the rectangle is making some angle with the vertical, as you can see here. In this case, it is a rectangle, and this rectangular surface is making some angle with the horizontal, obvious, of course. Then the small edge of this rectangle is also making some angle with the vertical. So when you see from the top, we will get the reduced shape, or when you see from the front also, we will get the reduced shape. In both the cases, we will not get the true shape. We will not get the straight line. We will get the reduced shape in both the cases. As you can see, the front view is the apparent shape. The top view is the previous shape that we have here. The top view is the previous shape that we have here. Then you can see here. Okay, so here the top view is the previous one. Top view is the previous one exactly. Even though it is twisted, the top view is the similar top view that we have got in the previous when the plane is making some angle with the horizontal. So the top view of the second case and in this case is same, but it is making some angle. This top view is making some angle with a vertical plane. That is only the difference, but exactly the shape is similar. The dimensions are similar in the second and the third in both the cases, but in this case the surface is making some angle with the horizontal, and in this case the surface is making some angle with the horizontal, and as well as the small edge of this surface is making some angle with the vertical. So both the cases we are considering here. The surface is making some angle with HP, as well as the small edge is making some angle with VP in both the cases. In this case, the top view is similar to the previous case, but the front view is the apparent shape. So now project all these points top, A dash, I'm projecting A dash to the top, then A1 here and A dash here. We will get A1 dash, B1 and B1 dash. We will get one more point here. As you can see, project all these points, A1 dash, A dash and A1 dash. Then we will get A1 dash here. Then similarly B1 and B dash, B1 dash, C1 and C dash, we will get C1 dash, D1 and D1 dash, we will get D1 and D1 dash, we will get here. Then these are the three cases that we need to follow while drawing the projections of the planes. Now let me move further to see the projections of the different shapes by considering these three examples, these three illustrations. Now, while solving a problem, so we have to follow some approach. As per our discussion, previous discussion, we have to follow the three steps. In the first step, assume the suitable conditions, draw the front view, top view for the initial position. With the given conditions, with the given dimensions, draw the front view and top view with the initial position. I will tell you what is the initial position in the next paragraph. Then in the next step 2, consider the surface inclination. Consider the surface inclination, then draw the front view, top view. In the first case, we are not going to consider, in the first step, we are not going to consider the surface inclination. That means in this case, we are going to assume the surface is parallel. Surface may be parallel to the horizontal plane or the vertical plane. That means in the step 1, we are going to assume the surface is parallel to HP or VP. That means it is not going to make any angle with HP or VP, which may be parallel to HP or VP in the first step. With that assumption, we are going to draw the front view and top view with the given dimensions for the given shape. Then in the step 2, we are going to consider the inclination of the surface. The surface can make some angle with HP or VP. With the given inclination angle, we are going to draw the projections for the surface or for the plane with the given dimensions. Then after drawing the front view and top view by considering the inclination of the surface, maybe with HP or maybe with a VP, then after we are going to consider the edge inclination, whether the edge can be having some angle with VP or HP. In the first case, I repeat, in the first step, we are not going to assume any inclination. We are going to assume the plane is parallel to HP or VP. With the given dimensions, we will draw the front view and top view. In the next step, in the step 2, we are going to consider the inclination of the surface, which may be either with the horizontal plane or with the vertical plane. Then in the third step, we are going to consider the inclination of the edge with respect to the reference plane, which may be either vertical plane or horizontal plane. In the first step, I said with you, we need to assume something, right? The actual problem maybe inclined to some reference plane, maybe edge may be inclined to the reference plane, but we have to assume to draw the actual drawing, the actual projections, with the given conditions, we have to draw the projections of the surface when it is parallel to HP or VP. Then after we proceed further to draw the considering the inclination of the surface with respect to the reference planes, then we will twist the edge with respect to the reference planes. Then we will consider the previous two cases to draw the third step. That means to come to the third step, we require the step 1 drawing and step 2 drawing. Totally we require the 3 steps. In first step, second step, drawings are required to draw the actual drawing projections in third step. So in the problem, the surface is inclined to HP. That means we have to assume that it is parallel to HP. In the problems, they give us that the plane, the defined plane, the problem plane can be inclined to HP or VP. If the plane given in the problem is inclined to HP, assume it is parallel to HP first. Then if the surface or the defined plane in the problem is inclined to vertical plane, assume it is parallel to VP first. This is the initial position. Then now if the surface is assumed parallel to HP, if the surface is parallel to HP, the top view will be the true shape as we have seen in the previous slide. When the surface is parallel to HP, the top view will be the true shape. If the surface is parallel to vertical plane, the front view will be the true shape as we have seen in the previous slide. Hence begin with drawing with the top view or front view. That means we have to start our drawing in the first step by drawing the true shape of the figure. If the surface given in the problem is inclined to HP, draw the true shape of the defined surface in the problem, top view, because top view is the true shape. If the defined surface is parallel to VP, the front view will be the true shape. That means we have to draw the front view first. If the surface is inclined to HP, we have to draw the front view first, assuming that the plane is parallel to VP. Then if the defined surface is inclined to HP, assuming that the plane is parallel to HP, draw the true shape. That means the top view will be the true shape. That means we have to draw the top view first. So while drawing the true shape, keep one edge perpendicular to XY line. So this is the assumption. One edge we need to make sure that the edge of the defined surface in the problem should be perpendicular to the XY line. Now complete the step 2. The step 2 is that twist the plane with reference to the reference plane, which may be horizontal plane or the vertical plane. Then draw the projections. Then twist the edge, one of the edge of the defined surface in the problem with respect to the reference planes and draw the projections. If we follow these 3 steps, we can solve the problem very easily. Now let me take one example to illustrate these 3 steps. A rectangle of 30 mm and 40 mm sides is resting on HP. One small edge is making, and one small edge of this rectangle is 30 degrees inclined to VP, while the surface of the plane is making 45 degrees with the HP. So the surface is making 45 degrees inclined to HP. the rectangle is 45 degrees inclined to HP, and the one of the small edge is making 30 degrees inclination with VP. This is the condition. Now let me show this problem first. Read out the problem. The surface is inclined to the horizontal plane, which is given to us. The surface of the plane making 45 degrees angle. That means the surface is inclined to 45 degrees. That means we have to assume the initial position. In the initial position, the plane is parallel to HP. So which view will show the true shape? That means in this case, the top view will be the true shape. In the previous slide, I told with you, when the surface is parallel to HP, the top view will be the true shape. Then in this case, one of the edge is small edge is making some angle. That angle is 30 degrees with the vertical. So this is what the summary of the problem. Now begin our problem with by drawing the top view below the XY line, because the true shape will be the top view when the plane is parallel to HP. So that we need to start our problem by drawing the true shape, because in this case it is a rectangle, and draw XY line. Then below that, draw a rectangle with the given dimensions. The length is 50 and height is 30. Construct the rectangle, assuming that the plane is parallel to HP. When the plane is parallel to HP, when we see from the top, it looks like a rectangle with the given dimensions. That is the true shape of the plane. Then name all those edges. I'm naming the edges as A, B, C, and D. Then when you see this plane from the front, it looks like a straight line with a given length, that is 50 here. And these distances are arbitrary distances. From the XY line, we are constructed the rectangle, ABCD rectangle, at a certain distance. And the front view is a straight line at a certain distance. We have to assume these distances from XY line. Then I'm naming these points as A dash, B dash, A dash, B dash in front view, top view ABCD. Front view I'm naming as A dash, B dash and C dash, D dash, like this. Then this is what initially I have assumed that the plane is parallel to HP. When the plane is parallel to HP, I have drawn the top view as the true shape. Then front view is a straight line. It's a horizontal line, which is on the vertical plane. And the true shape is on the horizontal plane, so that it is coming below the XY line. Then let me move further to see, by twisting this plane to a certain angle with HP. This is actual first condition. This is not our problem condition. This is we are assuming that the plane, initially the plane is horizontal to HP. To that condition, with the given dimensions, we have drawn the true shape, top view and the front view. But whereas in the problem, the plane, the rectangular plane is making some angle. That angle is 45 degrees with HP. So this plane is making 45 degrees with HP. Now this is horizontal now with the horizontal plane. Now I'm twisting this plane to 45 degrees. So now take a reference point on this XY line with the same dimensions. Here the length is 50. and draw a reference line, 45 degrees line here. Take a compass and take 50 mm length, and on this line and get a point for a length of 50 mm. Because the surface is inclined to HP, okay, and here the angle is 45 degrees angle. With this 45 degrees angle, draw an inclined line, here this is 45 degrees, here this is 45 degrees, and this is 50 millimeters. Okay, so because the length here is 50, and take a compass and take this length and draw a construction line at an angle of 45 degrees, and take a compass and take this length and get the points and A dash, B dash and C dash, D dash here. A dash, B dash and C dash, D dash here. Then project these points down to get the top view when the plane is making 45 degrees angle with HP. To that case, or in that case, we have to draw the top view. The top view is a reduced shape. This surface inclined to HP, but here the surface is inclined to HP, but here the surface is inclined to HP. So that is 45 degrees angle. Now when you see from the top, this is actually the front view. When you see from the front, you will get a straight line, but it is making 45 degrees angle. But in this case, it is not making any angle because it is horizontal. But now it is making some angle. That angle is 45 degrees. Now when you see from the top, it is a reduced shape. Then you project all these points like this. A dash, B dash and C dash, D dash. Project to get the top view. A dash and A, we will get 1 point here. We will get 1 point here. Then B dash and B, we will get one more point here. Then D dash and D, we will get one more point here. Then C and C dash, we will get one more point here. I'm naming these points as A1, B1, C1 and D1. Then join all those points to get a reduced shape when the plane is making 45 degrees angle with horizontal plane. So when this rectangle is making 45 degrees angle with HP, when you see from the top, it looks like this. When it is parallel, we will get the true shape. When it is making some angle, the shape that we get is the reduced shape. We will not get the actual shape, we will get the reduced shape. Now let me move further. In this case, we have one more condition. Along with this plane is making 45 degrees angle, as well as the one of the small edge is making 30 degrees with a vertical plane. That means one of the edge of this plane is making 30 degrees like this. This is actually the vertical. Then I'm drawing, of course, in this case, even you can draw like this, even this, you can draw like this. This is exactly the 30 degrees angle. With the 30 degrees, draw a reference line with 30 degrees angle. Then take the compass, and name this point. Project all these points and construct exactly this shape at an angle of 30 degrees. That is what the concept. Because exactly this shape needs to be twisted to 30 degrees. That's all. Exactly we will get the same shape. So the shape of the plane when it is making 45 degrees is same. We will get the same shape in this case also, but it is making 30 degrees with the vertical. Then let me take, okay, so now this I'm calling it as, take one point here on this reference line and A1, and take the compass, get B1 point, then get BC1, draw a straight line here, 90 degrees line here, then BC1, then CD1, perpendicular line, then project all these points to get the front view. Try to observe here. In first case, initially we have drawn the true shape, then projected upwards to get the front view. Then here we have drawn the front view first, then we have projected to get the top view. But here we have drawn the top view first, then we are projecting all these points to get the front view. This is what the hierarchy we need to follow, our procedure we need to understand, procedure we need to know to draw the projections in these conditions. When the plane is making some angle with the reference planes, as well as one of the edges making some angle with the reference plane. This is what the procedure we need to follow. Now in this case, one of the edges is making 30 degrees angle. I have drawn 30 degrees angle. I have constructed the same shape here by taking the same dimensions in compass, then project all these points to get the front view. In this case also, with this condition also, then B1 I am projecting to get the front view, then project here, we will get one point here, then project A or C here, we will get the C point here, then project all these points, then D we will get D1, D dash, then A1, A dash we will get one point here, then C1, C dash we will get one more point here, and B1 and B dash we will get one more point here. Then D here, so finally we will get the B1 and B dash here, then A1, A dash here, we will get first point, first, second, and we will get one more point here, and we will get the one more point here. So not this point, okay. So 1, 2, 3, 4 points. So join all those points as you can see here, okay. So to get the true shape, when you see from the front, when one of the edge is making some angle with the vertical plane, that angle is 30 degrees here. This is what the procedure we need to follow when the plane is making some angle with the reference plane, as well as one of the edge is making some angle with the vertical, that angle in this case is 30 degrees. Now join all those points to get the true shape when you see from the front. This is the front view when one of the edge is making 30 degrees with the vertical plane. Now let me go back what we have discussed as of now. We have taken only one example now. Then we have considered, we have followed the 3 steps procedure as we have discussed in the last slide. Initially, in the first step, we have to assume that the plane is parallel to HP or VP with the reference planes, one of the reference planes. Then we have to twist the plane with respect to the reference plane with the defined angle in the problem. Then we have to twist one of the edge with respect to the reference planes. To that we have to draw the projections. When the plane is parallel to HP, we have to draw the top view first. When the plane is parallel to VP, we have to draw the front view first, because the true shape we have to draw first. When the plane is parallel to HP, the top view will be the true shape, so that we have to draw the top view first. In this case, we have drawn the top view first. Then we have to use all these dimensions. When or all these projections in the next step, that is the second step. In the next step, that means in the second step, we are going to twist the plane to a certain angle with the reference planes. In this case, the reference plane is HP. The rectangular plane is twisted to 45 degrees with HP. So in the second step, I am drawing front view first, then I am projecting these points to get the top view. When we twist the plane to a certain angle with HP, the top view will be the reduced shape that you can observe here. When you project all these points from the first and as well as the second steps, we will get A1, D1, B1 and C1. This will be the reduced shape. Then in this case, the one of the edge of this rectangular plane is also making some angle with the vertical plane. In this case, it is 30 degrees, and take the compass. This similar shape construct at an angle of 30 degrees, then project all these points from the top view to get the front view in the second step. The top view of the third step and front view of the second step is projected to get the intersection points, and those intersection points are used to draw the front view when the edge is making some angle with the vertical plane. This is what we are obtained the points, then join all those points to get the shape. So thank you. I will stop here, and in the next class we will discuss few more points, few more examples by taking different shapes. In this case, in this problem we are taking rectangular shape. In coming session, I will give you a few more examples by considering set square with 30 degrees, 60 degrees in triangular shape. Then I will consider the pentagon. These two shapes we will discuss in our next session. So thank you one and all for this session.